Welcome to an exploration of one of the mind's greatest mysteries, the problem-solving paradox. To solve complex problems, our minds must somehow combine two fundamentally different ways of thinking: logical analysis and intuitive insight. Let's first understand these two distinct modes of cognitive processing. Logic operates sequentially, like following a path step by step. Intuition works holistically, grasping patterns all at once. Logical thinking is conscious and deliberate. It follows explicit rules and can be verbalized step by step. Intuitive thinking is largely unconscious and incredibly fast. It recognizes patterns instantly without conscious reasoning. We can think of logic as serial processing, handling one piece of information at a time. Intuition, on the other hand, is parallel processing, considering multiple factors simultaneously. But here's where things get interesting. These two modes are fundamentally incompatible. You might ask, why can't logic and intuition work at the same time? The answer lies in their neural basis. They rely on different, sometimes conflicting, brain networks. Logic requires intense focus on specific details, narrowing attention to examine each step carefully. Intuition needs diffuse, relaxed attention to perceive the big picture and notice subtle connections. We can express this as logical attention equals narrow focus, while intuitive attention equals broad awareness. These are mutually exclusive states. Let's look at what happens in the brain during each mode. The brain has distinct networks for logical and intuitive processing, shown here as different neural pathways. The executive control network, centered in the prefrontal cortex, becomes highly active during logical reasoning. The default mode network, which activates when the mind wanders, is crucial for intuitive insights. Research shows these networks are inversely related. When one is highly active, the other tends to quiet down. So how does the mind solve this paradox? Through oscillation. The mind oscillates between logical and intuitive modes, switching back and forth like a cognitive pendulum. In phase 1, logic analyzes the problem systematically, breaking it into components and examining relationships. In phase 2, intuition takes over, synthesizing information and spotting patterns that logic might miss. The complete solution emerges from alternating cycles of logical analysis and intuitive synthesis. Let's examine a famous historical example of this oscillation in action. Archimedes faced a complex problem: how to measure whether a crown was pure gold without damaging it. He spent days using logic, trying various direct measurement techniques, all of which failed for an irregular shape. Then, in a relaxed state in his bath, intuition struck. He noticed the water displacement and instantly saw the solution. The insight was simple. The crown's volume equals the volume of water it displaces. By measuring mass and volume, he could calculate density and determine if the crown was pure gold. But when should you switch between modes? This timing is crucial. Performance on complex problems follows a pattern. Logic provides steady progress, while intuition offers sudden breakthroughs. The key is to switch to intuitive mode when logical analysis starts yielding diminishing returns. Then return to logic to verify and refine the insights that intuition provides. Research suggests the optimal switch point is around 70% of your focused effort on a problem. Let's work through a classic puzzle that demonstrates this paradox perfectly. The 9-dot problem asks, connect all 9 dots using only 4 straight lines without lifting your pen. Logical thinking naturally assumes you must stay within the implied square boundary formed by the dots. Most people make over 50 logical attempts, all failing because of this hidden assumption. Intuition provides the breakthrough. You must think outside the box, literally extending lines beyond the dots. The solution requires breaking free from the mental constraint that logic unconsciously imposed. What's happening chemically in the brain during these oscillations? Different neurotransmitters dominate each mode: dopamine for focused logic, acetylcholine for relaxed intuition. Dopamine levels rise during logical thinking, enhancing focus and goal-directed behavior. Acetylcholine becomes more prominent during intuitive states, facilitating broad associative connections. The ratio between these neurotransmitters determines which mode is currently active. For logical thinking, the optimal ratio is approximately 3:1, favoring dopamine. For intuitive thinking, the ratio reverses to approximately 1:2, favoring acetylcholine. How can we consciously harness this oscillation in our own problem solving? Strategy 1. Use focused work intervals for logic, followed by relaxation breaks for intuition. A typical cycle might be 25 minutes of focused logical work, followed by 5 minutes of rest. Strategy 2. Many great thinkers used walks to activate intuitive mode after intense logical effort. Walking combines gentle physical activity with environmental stimulation, perfect for shifting to intuitive mode. Strategy 3. Sleep on difficult problems to allow unconscious intuitive processing. Studies show a 30% increase in problem-solving ability after sleep compared to staying awake. We can actually model the creative process mathematically. Creativity at any time equals the product of logical processing, intuitive processing, and their synergy factor. Logical effectiveness decays exponentially with time spent on a single problem. Meanwhile, intuitive insight potential grows as the mind processes information unconsciously. The synergy oscillates, representing the periodic switching between modes. This produces a wave pattern. Creativity peaks when oscillation is properly timed. Can we actually measure this paradox in action? In one fascinating study, 100 participants solved insight problems while brain activity was monitored. Those using only logical approaches succeeded just 23% of the time. Those relying purely on intuition did slightly better at 31%. But those who naturally oscillated between modes succeeded 68% of the time. This dramatic difference shows that oscillation isn't just helpful, it's essential for complex problem solving. The timing of oscillation matters as much as the oscillation it's. The optimal switching time equals problem difficulty divided by cognitive velocity. We can measure difficulty as the log base 2 of problem complexity. Cognitive velocity is your processing speed multiplied by working memory capacity. For most people and most problems, this works out to switching every 15 to 45 minutes. Think of problem solving like jazz improvisation. Jazz musicians must know music theory perfectly, then let go and improvise spontaneously. Logic is like music theory, providing structure, rules, and technical mastery. Intuition is the spontaneous creative expression that makes music come alive. Great jazz requires musicians to switch rapidly between technical precision and creative freedom. Let's examine common mistakes people make when trying to use both modes. Mistake 1. Switching too rapidly doesn't give either mode time to work properly. Each mode needs at least 10 minutes to reach effective operational state. Mistake 2. Staying in one mode indefinitely leads to diminishing returns and frustration. Mistake 3. You cannot force intuition to work. It requires a relaxed, receptive state. These 3 mistakes represent the most common ways people fail to properly harness the problem-solving paradox. When oscillation works perfectly, something remarkable happens. Insight emerges. Insight feels like a sudden flash of understanding, but it's actually the culmination of oscillation work. Insight is the integral of both logical and intuitive processing over time. The aha moment represents the convergence point, where logical understanding meets intuitive recognition. The probability of insight increases exponentially with time spent oscillating between modes. Can we improve our ability to use both modes effectively? Train logical mode through systematic analysis, mathematical problems, and structured reasoning exercises. Train intuitive mode through pattern recognition, visual thinking, and associative exercises. Both modes can be strengthened through deliberate practice, just like muscles. Skill in either mode equals practice hours multiplied by practice quality. Most importantly, practice the switching its. This metacognitive skill is learnable. This paradox manifests differently across various problem domains. In mathematics, logic dominates most of the work, but intuition guides which direction to explore. In art, intuition dominates the creative vision, while logic refines technical execution. Engineering requires balanced oscillation throughout the entire problem-solving process. We can define a balance ratio as the time spent in logic divided by time in intuition. Different domains require different balance ratios between logical and intuitive processing. Modern neuroscience has revealed the biological basis of this paradox. The brain has distinct networks for logical and intuitive processing, shown here as different neural pathways. The executive control network, centered in the prefrontal cortex, becomes highly active during logical reasoning. The default mode network, which activates when the mind wanders, is crucial for intuitive insights. Research shows these networks are inversely related. When one is highly active, the other tends to quiet down. The problem-solving paradox reveals a fundamental aspect of human cognition. By embracing the oscillation between logical and intuitive modes, we can solve complex problems more effectively. The future of problem-solving lies in understanding and harnessing this paradox, leading to breakthroughs in science, art, and innovation.